Azure platform,
Yeah, please continue.
using Azure Databricks, Data Factory, and other related Azure services like Azure Data Lake Gen 2 and Azure Key Vault, etc.
Mm-hmm.
So in this project, we are collecting data from ERP systems like Oracle Fusion Cloud and PeopleSoft, which is an on-prem system, and also other custom payment solutions. And we
Mm-hmm.
are building a pipeline, data pipeline, and using this pipeline, we have implemented medallion architecture. And this data, after all the aggregation and transformation, is being used for reporting and downstream purposes.
Mm-hmm. Okay.
Yeah,
So, uh, the currently you are working in this Law Services India Private Limited,
yeah.
and in this particular company, you have done. So, can you please explain your project in a more detailed fashion? What was the source? You fetched the data, and how did you like loaded the data into the data lake? What kind of pipeline you have built? Just end-to-end architecture. Can you explain your project once again?
Yeah, sure. So, data comes from, we have data coming from multiple sources like Oracle Fusion ERP and other is Oracle PeopleSoft. These are two main sources. In addition to that, we have other small custom built applications which also send us data. So, primarily the data comes in CSV and JSON format. So this data is placed in SFTP folders or buckets like cloud buckets. So we use Azure Data Factory to connect to these systems and using different connectors. If it is an on-prem, we use self-hosted integration runtime, and if it is a cloud system, like we use the corresponding connector. For example, for connecting to data lake, we use data lake connector and then get the data and store it in our bronze layer as a in the raw format. And then in silver layer, we fetch the data from bronze and then apply necessary initial transformations and data quality checks and column level column name changes and filter out the data which are not required, add audit columns. We perform all this and then save it in our silver layer. And in our gold layer, like we perform aggregations on the cleansed data. And then using this gold layer, we serve it to reporting purpose as well as downstream people have access to this, so they consume it from there for their need.
Mhm. So you have done the data transformation in Databricks. Then after that, like from there itself you are doing the reporting, or you're moving the data to SQL Server?
Yeah, like we have two different scenarios. Like few tables we do save it in Azure SQL Server, and a few of the tables we save it as Delta tables only. So they are present in both SQL Server and Delta tables.
Hmm. Okay, and in which cases you do use Databricks, and in which cases you use the SQL Server?
Yeah, for whenever like for downstream systems, like when they are using for analytical purpose or using it for further processing, we save it in Delta Lake and then they consume it from there. And for reporting purposes, we have saved it in SQL Server. So
Hmm.
from there they
Hmm.
consume it for reporting.
Okay, okay, fine, understood. What is medallion architecture? Can you please explain me?
Yeah, so basically medallion architecture consists of bronze, silver, and gold layers. So the bronze layer contains the raw data as is from the source in the native format, and the silver and gold layers contain in the format which is suitable for our Databricks application. So it's in a Delta format, Delta or Parquet, and so silver layer contains a clean form of data with little transformation, and gold layer contains all the aggregated data with necessary transformations applied, which is as per the business specification, like how they want to consume it. So it will be in that format. So this is
Hmm.
the explanation for medallion.
Okay. Uh, what is the difference between uh, data lake delta lake and delta table. Can you please explain?
Yeah, data lake is basically a storage solution from Azure. So, like, it's just a cloud storage. We can use it for any purpose, like storing flat files, images, audios, whatever we want. We can use it as a general purpose storage. And like ADLS Gen 2, like, is more suited for uh, high performance applications. Basically, it is Hadoop compatible and has all the advantages like hierarchical namespace, role based access control, etc.
Mm-hmm.
And delta tables are like, a specialized format built on top of parquet files. So like that it has like additional features which support data lakehouse architecture, such as support for ACID transaction, like data governance using audit. Basically, it has a transaction log on top of Parquet files, and which contains the metadata information, such as the number of inserts, updates, deletes, which helps to achieve time travel. And also, it supports upset and delete operations, which were not possible in Parquet files.
Mm-hmm.
So this is an example of this is the advantages of using delta tables. And when we have uh, more delta tables placed together, we call it delta lake.
Mm-hmm. Okay. And okay, fine. And what's the difference between delta load and delta lake?
Yeah, delta load is an incremental load term used in incremental load strategy. So
Mhm.
in incremental load, we have two types, like full load and incremental load, or delta load. So the smaller
Mhm.
portion of data which comes every day into our system, we call it as delta loads, and
Mhm.
full loads we contains the history data.
Mhm. Okay. Okay, fine. Uh, Now I'm giving you a scenario. So suppose you have a SQL database, SQL server, and in the
Okay.
SQL server you have like five different databases. Now you want to pull five table from each of the database into data lake. And yeah, so this is what you want to do. You want to do it incrementally or like full load manner, whatever, yeah, you want to do. Then for this particular case, when you have one SQL server and five database, and in each database you want to pull five table, how would you make the pipeline for this to load the data into data lake? The source is on-premise SQL server. So how can you design the pipeline for this?
Yeah, so first we will get the database name and table name. If the all the databases are hosted in a single server, we can use a same self-hosted integration runtime
Mm-hmm.
on that server, and then we can get also use a metadata file or table as per
Mm-hmm.
our convenience. It will contain the database name and the table name that we wanna pull.
Mm-hmm.
Also, if we want to do full load or incremental load, we can use the watermark column, however it is present in the source, and as well as in the target. Like, we can use a watermark column, like to
Mm-hmm.
understand the ingested date and modified ingested or modified date. And
Mm-hmm.
we can use in Azure Data Factory. We can connect using we can use the lookup activity to get the table information and query the data from those tables by using a parameterized data set. Like from the lookup activity output, we can get the name of the database and the table name, and then using copy data activity, we can process the copy activity. And if you want to do parallel, or if you want to do a serial way, we can use it depending on our need and compute resources available.
So you can make one pipeline, or you will make five different pipeline for like five different database.
Yeah, like we can use a single pipeline. Like, if compute resources and time is not a problem, we can use a single pipeline. it's not an issue.
But
But if
in when you make a link service there, we need to give the database name as well, right? So how can you design the pipeline like that?
okay, yeah, like no, yeah, in the we can have in that case we can have different five different link service corresponding to a single self-hosted integration runtime, and use each link service for each copy activity. So in that way
Mhm.
we can achieve that.
Okay. Okay, so you'll make five different pipelines, and then suppose if I want to do delta load as well, then you'll make 10 different, like 10 pipelines totally, right? Suppose for each table I want to set up delta load and also full load, you'll make five more pipelines. So total 10 pipelines you'll make ideally, right?
No, like we no need to make five different pipelines again, because we can achieve full load and incremental load using the same logic. Like as we are using watermark column, we can for a full load we can set we can set the date to a earlier date, say 1900 or something, to any arbitrary early date. So using that, our logic will pick up and process incremental load, and if it is a delta load, the max modified date column in the watermark will help us to achieve this. In that way, we no need to have two different pipelines for full load
But
and increment.
but when you get the incremental load, which will be the full load, whenever you want to do the full load, you will again use the absurd concept instead of truncate and delete, right?
Yeah,
Which gives you a lower performance, because ideally when you do the full load, you just truncate and load the whole data. And when you're doing the absurd concept, you will match each of the primary key of the load which you got, and then one by one you do the load, right? Which will take time.
yeah. It again depends on the volume of data that we are using. So if we have a large volume of tables, and also it depends on the strategy where we are placing the files. If we
Mm.
are placing getting the data from tables SQL Server on-prem and placing it in a Delta Lake in a flat file format, we can save the files using dates, like in a folder, a separate folder for each date, and then we can process them. And
Mm.
to process full load using upsert, like only the meta small, I mean, if the delta load is small, we can use upsert, and it will be computationally efficient, and it will not have much overload. But
Mhm.
if
Okay.
the delta load is also huge, then we need to decide the strategy which will suit for our need.
Mhm.
Either we need
Okay.
to drop and recreate, or like we have to use delta load. We have to decide on that.
What is metadata activity, and in which cases we use the metadata activity in data factory?
Yeah, so get metadata activity is used to get the folder and file metadata from ADLS. Like I have used for that, and we can get the child items, last modified date, file size, like all those. We
Mm.
can all those metadata information we can get using metadata activity. So suppose
Mm.
if we want to um, run a pipeline depending on the modified date of a file, we can use the metadata tree, get the last modified date, and then depending on the date we can use our
Mhm. Mhm.
pipeline.
Okay. And suppose if I want to trigger my pipeline every Friday, uh, yeah, every Friday I want to trigger my pipeline. Which particular trigger I will use in Data Factory? Every
Yeah,
Friday at 10 p.m., for example.
okay. Yeah, there are two triggers, basically schedule trigger and tumbling window trigger, and it depends on our need. So, like if we want, if it is a simple use case, and we can use a schedule trigger. Like schedule trigger has one to many mapping. Like we have, if we have other pipelines also running at the same time, and if we want to use the existing trigger like that is already available, we can use the schedule trigger. But if you want to use a one-to-one mapping, and also like we don't want subsequent run of our pipeline to run until unless this previous run is completed, we can use tumbling window. But in this case, like we are running only once a week, so scheduled trigger might be a, good option.
Hmm. So in this case, when you want to run the pipeline every Friday 10 p.m., then you will use the schedule time trigger, right?
Yeah.
Okay. And can I make a trigger and that particular trigger I can use in different pipeline, or I need to design different triggers for all the pipeline?
Yeah, if it is a scheduled trigger, we can use it in other pipelines as well. And if it is a tumbling window trigger, we can use it only, it's exclusive to the pipeline, and
Hmm.
we can use it for only one pipeline.
Okay. What's the difference between a blob storage and data lake Gen 2? And
Yeah,
also
so
why there is a need of moving to data lake Gen 2? Then what's the need of moving from data lake Gen 2 to creating a delta table and delta lake? What's the benefit it gives you when you do that?
I didn't get the second part
So
of the question.
suppose,
Like,
yeah, so you have a blob, we upgraded to data lake. Now from data lake, we also want delta lake. So from data blob storage, what's the benefit it given you so that you switch to data lake? And from data lake, what's the benefit you're getting when you move to delta lake?
okay, so primary difference between blob and the data lake is that like it has hierarchical namespace structure, and
Mhm,
also it supports role based access control, and
mhm,
other advantage is that ADLS is like Hadoop compatible storage,
mhm,
especially when we are using with Databricks or any Hadoop related workloads. Like we can prefer ADLS Gen 2 for a higher performance.
mhm,
And to answer the second question, like whenever we have a delta table, and we need to share it with other team or any other downstream applications, like we can give access only to that particular table in for example, there are 10 tables in a gold layer, and
mhm,
we need to provide access only to a particular table. We can do
mhm,
that in data lake Gen 2 using role based access control. And
mhm,
but that is not possible in blob storage, so we get this advantage if you want to give fine grained access to particular um, folders, like we can achieve that using data like Gen 2.
mhm. Okay. And what's the need of moving from delta lake to delta lake? What's the benefit it gives you?
Sorry, data lake to delta lake.
Yeah.
Yeah, data lake is just a storage format, right? Delta provides you additional advantages such as ACID transaction. For example, keeping a simple Parquet file in data lake and having a delta table has numerous advantages like ACID transaction support and support for upserts, like and data governance, like if through
Mm,
audit, and other performance improvements which comes with the delta lake, such as delta cache, and
mm.
so these are the advantages, I
Okay.
can say.
What's the difference between a serverless pool and a dedicated pool in Synapse? Uh,
Yeah,
Azure Synapse?
yeah. So serverless SQL pool is a managed service provided by Azure. So if you wanna run simple computational queries on top of tables from Data Lake, we can use serverless SQL pool. Whereas dedicated SQL pool is a full-fledged data warehouse. Like if you want to run queries on top of structured data warehouse tables, we have to go for dedicated SQL pool.
Mm. Uh, so in which cases you will use a serverless pool and in which cases you will use a dedicated pool? Like,
Yeah.
yeah.
uh, So if we are connecting to a data like Gen 2, and then there we have delta tables present and we want to query them, we can go with and it is used only less frequently, or it does not require much computational power. And like if it is we are not doing any big aggregations or something like that, like heavy transformations, we can go for serverless SQL pool. And we
Mhm,
if we want to use structured tables, like and it is used for reporting purposes or any other heavy computational purposes, we can go for uh, dedicated SQL pool.
What's the benefit of using Synapse over Data Factory? And what's the benefit of using Data Factory over Synapse?
Yeah, Synapse like is provides a unified platform like where we can use instead of using Data Factory, Databricks, and different Azure SQL Server like for a data warehouse, we can combine all these three and we can use it in a Azure Synapse platform. But when we want to use like high concurrent or high demand big data pipelines, we can go for Databricks as it provides more optimization on top of Spark and has high concurrent and job clusters in Databricks. We can prefer Databricks for that use case, like when we want to process yeah, big data
I
load.
asked Data Factory and Data Synapse, not Databricks and
Okay, Data
Synapse.
Factory, like yeah, so Data Factory has limited processing and transformation capabilities. Like if we want to orchestrate a pipeline and only use it for that orchestration or perform simple transformations, we can use prefer Data Factory. But on the other hand, like if you want to perform larger transformations on structured tables, like we can use Azure Synapse.
Mhm. Okay. Okay, fine. Now, when it comes to your skill, Data Factory, Databricks, Synapse Analytics, SQL, Python, can you just like let's talk about first language. So, which language you prefer to write your code, either SQL or Python? Which language you prefer?
Yeah, like I prefer to use PySpark and SQL both interchangeably. Like for some transformations, like which are harder in PySpark, like I prefer to use SQL, and like others, like which are
So both
easier.
both language you can use, right? Ideally.
Yeah, yeah,
And which tool you prefer? Data Factory, Data Bricks, or Synapse Analytics?
yeah. I prefer Databricks and Data Factory. Data Factory for orchestration and Databricks for transformation.
Okay. Now, what is Unity Catalog in Databricks?
So Unity Catalog is a recent feature released by Databricks. It provides a data governance feature and unified storage platform for on top of Azure Data Lake. So whenever we want to access the delta underlying delta tables across multiple data factory instances, we can go for Unity Catalog. In addition to that, like the Unity Catalog provides multiple benefits such as data lineage and data governance. Like rather than using a additional role-based access control, the roles and role-based access control is inherently present within Unity Catalog.
Okay.
So and
Okay.
especially data lineage is one of the unique features, like where we can understand how a, table is getting transformed, and if in case of troubleshooting a pipeline, we can understand from which notebooks we need to check and modify to troubleshoot it faster and
Mhm.
understand the upstream and downstream tables. It will be
Mhm.
helpful.
What is cache and persist in Databricks?
Yeah, both cache and persist are used to improve the query performance. So whenever we have multiple operations performed on a data frame, as Spark runs entirely on in-memory computation. Whenever we have multiple intermediary steps, when we call the last step, like Spark has to recompute all the steps, like for example, read and then aggregation, and then again if we are doing third level of aggregation, so if we call a third level of aggregation, it has to perform all the above two steps and then again compute the third step. So if we want to achieve if the third data frame is being used repeatedly, we can cache the data frame at any one of the levels. So it is cache or persist the data frame at any one of the level, and it will improve the performance as the data frame is permanently stored in memory rather than performing the computation again.
Mhm.
So cache has persist is preferred over cache because persist has some additional features on in addition to cache. So like it has option to use memory and disk off heap. So all these additional features are available, and also if we are done with processing, rather than waiting for it to leave automatically, which is the case in cache. We can do unpersist. It will clear the memory in Spark.
So you will use persist over cache always?
Yeah,
Always.
yeah, yeah. If it is a smaller use case, like we can go with cache, but if it is a bigger data frame, like we can go with persist because
Hmm.
it gives more control.
Okay, so why there is a need of cache then if you want to always use persist?
Yeah, if it is a smaller data frames and we want to use the inbuilt garbage collector from Spark, we can use the cache option. But
Hmm.
for larger data frames, we can use uh,
Hmm.
persist.
Okay. What is adaptive query execution and catalyst optimizer in Databricks?
Yeah, so whenever we run any Spark job, like whenever we perform any transformation logic inside that, the code is submitted to the Catalyst optimizer, which which applies several logic on top of that transformation. So the stages include parse logical plan, analyzed logical plan, optimized logical plan, and physical plan. So the code goes through all these four phases, and finally in the physical plan it creates the DAG. So and adaptive query execution is additional feature provided by Azure Databricks, where it provides additional features such as like predicate push down, and it improves the performance further on top of Catalyst optimizer.
Hmm. What are the performance improvement it does?
Yeah, it filters the especially in case of joins. If the join is on a smaller data frame and a larger data frame, it automatically applies broadcast join. And if both the data frames are larger, by default it applies short merge join. So
Hmm.
these are some features I can remember.
Hmm. Okay. Uh, and what are the Spark optimization technique you generally used in your notebook? What are the optimization technique you do to optimize your code in Databricks?
Yeah, so as we discussed earlier, one of the optimization technique we can use is the persist and cache. When we are dealing with multiple intermediary stages in a data frame, we can use persist or cache. And other optimizations include whenever we are joining tables, larger tables, we can check for data skewness by using the partition ID and partition ID column and partition ID, and check whether the data is queued or distributed equally among the partitions. So we can use a salting technique where data is distributed equally based on a salt variable, and or we can use salting, or we can also use repartition before performing the join. So
Hmm.
and there are other optimization techniques, but it depends on the use case. Like we need to check and then
What's
do
the
it.
difference between repartition and coalesce?
So repartition and coalesce both are used to change the number of partitions in a data frame. So repartition can both increase and decrease the number of partition, whereas coalesce can only reduce the number of partition. And repartition is a wide transformation. Coalesce is a narrow transformation, and we use coalesce generally when we are reducing the data. And for example, when we are writing the data to a single file, we can use coalesce and reduce the number of partition and save it to a file. Whereas when we wanna partition data before join operation, we wanna have equal number of data without data skewness, we can use repartition.
Hmm. Okay. Uh, And in your project, like how much of a data you used in general to what was the size of the data? And then what was the team size like in which how much was the team size when you were working?
Yeah, there were like the team size, like we had around four data engineers and one lead data engineer.
Hmm.
And depending on the data volume, like it depends on different basis. Like we have tables coming in weekly and daily.
Mm,
So and few tables have like size of around 400 MB, like or 500 MB, and few tables are like smaller, like comes around 12, 13 MB, or like in tens of MBs. So it depends, and also it depends on the month, or like fiscal year, like which we are dealing with. So in case of financial closure or any other activity,
mm,
we can expect, or a high sale date, we can expect large amount of data. But
mm,
if it is a regular day, we can assume an average around 400 or 500 MB of data coming in
mhm.
per day.
Okay. And now I will and you were in this agile development or a waterfall, like which particular development practicing you were following?
Yeah, we are using agile methodology.
Can you explain what is agile methodology?
Yeah, so rather than whenever we are developing any software product, when rather than waiting for the entire product to be completed and then tested and to be released, we are breaking up the bigger deliverable into a smaller compartments, so that each deliverable is worked upon faster and then delivered quickly. So
Mm,
we are basically breaking a bigger problem into series of smaller problems and then continuously delivering it. And
mm,
then in that way we can achieve, as the problems are smaller, we can work together and complete it in a faster way and
mhm.
efficient way.
Okay.
So,
And now I will give you some of the simple like questions. So if you want to read a particular CSV file in Databricks, how will you read it? Can you share your screen probably and write it in the notepad?
yeah, sure. Like screen sharing is disabled also.
Okay, so can you 1 second? Yeah, 1 second. I will give you the permission. Yeah, please.
Screen got froze. Like, are you able to see my screen? Like,
Yeah. Mm, I am able to see your screen, but not notepad. I'm able to
yeah,
see the
I
Zoom. Huh?
open. Just give me a minute. Let me close. Yeah.
Hmm.
So,
How do you read a normal CSV file?
like assuming we have a CSV file which is accessible in a mount or any
Yeah,
location.
yeah.
CSV, and we have options like we can define the schema depending on the table, and header option also we can provide, like, yeah, this one of the
Hmm.
examples.
Okay. And so you write options as well, yeah, right?
Yeah, we can use like that way as well, like spark dot read dot option, and then like we can define header, like header
Hmm.
equal to true,
Okay.
then we
Yeah.
can use either
And
way.
so suppose if you have a table, and in a table you have employee name and uh, like just like employee ID, employee name, and salary, and manager ID.
Okay.
Manager ID. Okay.
Okay.
Now, if you want to find out, so suppose, yeah, so employee ID one, name Abhishek, salary, suppose 10K, for example. Manager
Okay.
ID is like like two, for example, right?
Okay.
Then what I want to understand is how I can find out which employee is earning salary more than his manager. That is what I want to find out. How I can write a query for that.
Okay. Yeah, I think this will.
E dot manager ID equals to. Okay, can you write the same query in PySpark?
Yeah, sure. So here I can read the data frame as like I can read the same data frame twice, like and EMPDF. So yeah, I think this will work.
Hmm. Okay. Um, yeah, so yeah, so that's all for the interview, Deepak, what I wanted to ask. Thank you for your time. And now I
Okay.
will stop the recording.